Hey guys, Mr. Martin recording a video on volume. We'll just be doing sample problems instead of taking notes. I am working from your textbook. I am on page 465, and I'm starting with number 12. I've already drawn the curve and the rough sketch of how it should look in the region that we're rotating around various lines. So for part A, we're to take this shaded region and rotate it around the y-axis. So I'll be using different colors for each problem. For A, I'm just going to use blue. So we're rotating around the y-axis. So if we rotate this shape around the y-axis, it is going to require that we use the washer method because we're going to have a hole in the graph, which means we're going to have an inner radius and an outer radius. So for part A, we need to determine our outer radius and our inner radius. The outer radius is always going to be 2 because the distance from the axis of revolution to the end of the solid is always 2, no matter where we are. So the outer radius is 2, and the inner radius is the distance from here to here is an arbitrary x value. So remember, whatever axis we're rotating around, that determines our variable for integration. So our outer radius is 2, our inner radius is x, but we want to express x in terms of y. So x is going to equal, we divide by 2 and take the square root. So x equals the square root of y over 2. And so when we set up our volume, we will have v equals pi times the integral from 0 to, all right, so our x's are going from 0 to 2, and so our y's should go from 0, if we substitute in 0 into this function, we get 2 times 0, which is 0. And let's write this down. So 0 is less than or equal to x, is less than or equal to 2. And so we just substitute our x's into this equation. So when x is 0, y is going to be 0. And when x is 2, 2 squared is 4 times 2 will give us 8. So our y limits are from 0 to 8. And our outer radius is 2 squared minus the inner radius is going to be the square root of y over 2 squared dy. So when we simplify, we get pi times the integral from 0 to 8 of 4 minus y over 2 dy. And if we integrate further, I actually don't want to do the calculation by hand. We'll just substitute it into the calculator. We'll get out of here. Math 9 from 0 to 8 of 4 minus. So y divided by 2, we're going to use x instead. And when we, not graph, meant to press enter, we get 16. So this is going to equal 16 pi. Now this may be something we can verify pretty easily by substituting in, by actually integrating. So we get pi times 4y minus y squared over 4 evaluated from 0 to 8. And if we substitute in 8, we get 32 minus 8 squared is 64 divided by 4 is 16. So 32 minus 16 will still give us 16 pi. So that's it for part A. Again, we had to do the washer method because the solid would have had a hole in it when rotating around the y-axis. For part B, they want us to rotate around the x-axis. So we'll put part B right here, and it says x-axis. So when we're rotating around the x-axis, we're taking the same solid, but in this case, we get this as our arbitrary radius. So because the solid will have no hole, we can just use the disk method. So for part B, our radius is y, but since we're rotating around a horizontal line, we want to express this in terms of x. So since our y value is dependent upon what x is, we know y equals 2x squared. So our radius is y equals 2x squared. And so our volume is v equals pi times the integral from 0 to 2 of 2x squared squared dx, which simplifies to be pi times the integral from 0 to 2. 2 squared is 4, so we will get 4x to the fourth dx. And so if we integrate that, we would get pi times 4x to the fifth over 5 evaluated from 0 to 2, which if we substitute in 2 to the fifth is 32. 32 times 4 is 128. So we get 128 pi over 5. This is a value that we can verify by using the calculator as well. So we do math 9, 0 to 2 of 4x to the fourth dx. And then we're going to say times pi. So let's look at, so we got 80.4, so 128 divided by 5 pi, and we get the exact same value. So this is how we know it's correct. For part C, they want us to rotate around the line y equals 8. So for part C, let's use a much different color. So for part C, we're using y equals 8. So we're rotating around this line. So again, this is going to be a situation where we have a hole in the graph, which means we need to use the washer method. So first we determine our outer radius. So the outer radius is going to be the distance from the axis of revolution, which is y equals 8, all the way to the end of the solid. So this distance is consistently going to be 8. So our outer radius is 8, and the inner radius is going to be the distance from this line to this curve, which is going to be 8 minus, what is this, 8 minus y, so 8 minus y, and that's going to equal 8 minus, we express y, so 8 minus 2x squared. So yeah, so our outer radius is 8, our inner radius is 8 minus 2x squared. So our volume, we'll keep this, so our volume is pi times the integral from 0 to 2 of 8 squared minus 8 minus 2x squared squared dx, which we would get pi times the integral from 0 to 2 of 64. If we multiply, so we'll just say 64. So 64 minus 8 minus 2x squared squared dx. And so this is something we'll throw into the calculator as well. We have math 9, the integral from 0 to 2 of 64 minus 8 minus 2x squared dx. And we get 59.733, which as a fraction is 896 pi over 15. So the way we could have worked this also is to expand this out, and we would have gotten, we'll say pi times the interval from 0 to 2. So 8 squared is going to be 64. So this 64 and this 64 cancel. So we're left with negative 16x squared times 2. So 32x squared, and then negative 2x squared. Squared is going to be negative 4x to the fourth. I mean, positive 4x to the fourth, and then we distribute a negative, so minus 4x to the fourth dx. And let's see if we get the same thing. So math 9, integral from 0 to 2 of 32x squared minus 4x to the fourth dx. And so we still get the 896 over 15 either way. For part D, we're rotating around the line x equals 2. So when rotating around x equals 2, we have this solid that's going to have a distance of, so again, the distance from the axis of rotation into the curve. So from 2 to here is going to be 2 minus x. So for part D, it's the line x equals 2. And the only radius that we have, because it's going to produce a solid with no hole, so our radius is 2 minus x. But since we're rotating around a vertical line, we need to express this in terms of y. So it's going to be 2 minus, we already determined that y was, x equal the square root of y over 2. So our radius is 2 minus the square root of y over 2. And so our volume is pi times the integral from 0 to 8 of 2 minus the square root of y over 2 squared dy. Even though it seems tricky, this is still algebra that we should be able to do. So if I ask to expand this, we would get 4 minus 4 square root y over 2 plus y over 2 dy. And so when we plug this in, we're going to have math 9 from 0 to 8. And initially, we're going to do 2 minus the square root of x divided by 2. I cleared it out. So 2 minus the square root of x divided by 2 squared dx. And what's the hold up? We get, I think this is an irrational number. So 5.33 pi. So equals 5.33 pi. And we're going to see if we integrate this same result that we expanded, if we get the same thing. So math 9 from 0 to 8. So we're going to have 4 minus 4 square root x over 2 plus x over 2 alpha equals x over 2 dx. we do get the same value, so we get 5.33 pi. All right, so these are more examples of us doing volume by the disk and the washer method. Pay attention to D, that it produced a disk method question which required us to do something to the radius where we did 2 minus x. If you have questions, come by and see me, or I'm pretty sure I'll upload another video of me working problem number 17 and problem number 19 in the future.